Let's go back to that and see. Watch. This is not drawn to scale. That's 6. That length, there's no way that's 6 right there. So, because look, this is 6.5. There's no way that's 6 because the hypotenuse has to be the longest side, doesn't it?
Yeah.
All right, so there's no way that's 6. So the 6 probably ends right here. If I took this and swung it around, watch what's going to happen. It's not going to hit that AB. It's probably going to hit around here somewhere if that was actually 6 compared to that height. So that'll never form a triangle. If it never forms a triangle, then we have no solution. We can't get an angle here because it's not even a real triangle, is it? Because it doesn't all come together. All right, you could do this as well. Watch. Let's just say we didn't realize all that. We didn't remember that little chart. We didn't remember about this thing being shorter than this side and all that kind of stuff. What if we just went straight ahead, full bore, and we said, let's just do lost signs. Let's see what happens. All right, you're saying, okay, well, let's just see. I bet you lost signs works anyway. I don't believe Hamrick. I don't believe, that doesn't work. I'm going to do lost signs. I'm going to prove him wrong. Okay? Yeah, exactly. That's because this comes all the way down here. Remember, it's not drawn to scale necessarily. All right. So let's solve for angle B. So let's do lost signs really quick. So it would be the sine of B over 8 equals, here's the two things we know. So that'd be the sine of 54 over 6. Right? Multiply both sides by 8. Do this in your calculator. Take the inverse sine of it. And guess what you get for angle B. You look in your calculator, give it a shot, and it's going to say error. All right? Which means there's what? There is no solution. All right? There it is. So there's a case. So what have we done so far? We've done one where we've had one solution. We've done one where we had no solutions. Guess what's next? Two solutions. Two solutions. All right, here's our situation. Again, what do we have? We have two sides and what? One angle. Okay, it's an acute angle this time. So we know we have a possibility, don't we? It's not an obtuse angle. Actually, we got 0, 1, or 2. We've got to figure out what it is. So let's see what we have. We have an acute angle. Look at the side that's opposite the acute angle. If this is angle A, this would be side A. We're going to look at our chart. Our opposite side is going to be less than the other side. Do you see that? Let's go to the chart and see what our situation is here. Here's our situation. A is acute, so we're going to use one of these things right here, aren't we? We got to compare it to the height, don't we? All right, so let's go back and figure out what the height is real quick, and we'll compare it and see whether we have no solution, one solution, or two solutions. All right, so there's the height again. We've done this before. Let's do this. This is our angle, 35 degrees. This is our height. So we go opposite over hypotenuse. So it's the sine
Please come to the office.
of 35 degrees equals the opposite over the hypotenuse. Multiply both sides by 20. So H is, let's see, it's 11.5. Okay, you can do that on your calculator. So this height right here is 11.5. Notice, let's compare the three sides because that's what we're going to do on this chart. The opposite side is like the middle side, isn't it? All right. The other side, we'll call it that, the other side is the largest. The height is the smallest. So watch, the height is the smallest out of these three sides. Remember that? Okay, let's go to that chart and see what we have. Look at this. Right here it says the height is larger than the A. Is that our situation? No, it's not our situation. So we're not going to have no solution. So that means we're going to have a solution, right? Let's go down to this. Look at the height. What does this say right here? H is it's the smallest, right? It's smaller than the other two, right? The A, the one that's across from the angle that they gave us, is the middle one, right? And the other side, right, the third side, is the largest. Do you see how that works? So that's our situation, isn't it? It's exactly what it is. So how many solutions are we going to have now? We're going to have two solutions for this. And this is where it gets a little bit weird. So how much time is this? What do I got? 12 what? 4 minutes? Okay. Let's do this. Yep, let's just do everything the way it is right now. Let's solve for B. And I'll just do this in, let's do this in blue. Okay, so I'm going to solve for angle B. So let's see what we can do. Just using the law of sines, right? Sine of B over what? 20. Are you getting used to this now? Equals the sine of 35 over 17. All right? Multiply both sides by 20. Take the inverse sine, right? Second function sine. Put that in your calculator, second function sine. So angle B, let me flip my paper over here, is going to be 42.4 degrees.
Yep, 42.
Yep, 42.4. Okay. Now watch. Angle C. I'm not going to show you the work. Let's just do it. This is 42.4. How do we find big angle C right up here? Just take them away from 180. So you can do that on your calculator. It's 180 minus 35 minus 42.4. And I do that and I get 102.6. All right, so this angle right here, just put a little arrow there, is 102.6 degrees. Okay. Let's find side C. Where's side C? Side C is this whole entire thing right here, isn't it? You see that? So how do we do that? Put C on the top, because that's what we're solving for, over the sine of 102.6 equals, we can use any of the other things. Let's use the original stuff they give us. So it's 17 over sine of 35. All right, multiply both sides by the sine of 102.6. All right, no inverse, right? Because it's just C is equal to all this stuff, and C is 28.9. All right, so look what we have. Let's write this down here, actually. All right, we good so far? Let's do this. Let me just... You saw how we did this. I need some room, so I'm just going to get rid of this. All right. So that's what we have right here. And you say, okay, well, that's fine. What's the big deal? But watch this. Okay? You got to use your imagination a little bit. Watch this very carefully. See this 17 right here? We could take this, okay, and swing it around.
Make like another 7.
Watch. We could take this. You watch and don't leave yet. Okay, it's only lunch. Okay, just give me a second. We could take this 17 and we could actually swing it around. It's going to go below here. Watch what it's doing. Oops, I got the wrong thing. No, watch. Don't move. Don't do anything. Just watch. I could take this, swing it around, and then it would land somewhere around in here, wouldn't it? Do you see that 17? So watch, I could take this. Now it's not exactly precise, but it'll probably be around in there. That looks pretty close, doesn't it? Now watch this. This is 17 now. Now I've got a completely different triangle, don't I? Given the same information, look, I was given this was 35, I was given this was 20, and I was given a side 17. Isn't that the same information that was given for the other triangle? But now it's a completely different looking triangle. You can do the work. It's on the first class if you want to look at the first class. Okay, I found this angle, and I found this angle, and I found this side right here. And they're all completely different than this. That's the two answers, okay? That's the two different solutions that we have for this. And that's the situation that it works, okay? Look at the first class. I went through all the work on how to get those, okay? No homework tonight. We're going to give some tomorrow, though.
So is that the reason why there is no SSA postulator theorem, congruence postulator theorem?
Yes, exactly, because you can have two sides. Exactly right. So that does have a relationship, which you were asking before. So you're absolutely right. I can give two angles and a non-included side and get two completely different triangles. That doesn't mean they're going to be congruent to each other.
Wait, two
and you're
angles on a non-included side would still give you the same one, right? It would be two sides on a non-included.
What did I say?
You said two angles.
Oh, did I didn't say right. Two sides and a non-included angle.
Do we have
Right,
homework
right.
tonight?
Included.
No.